Hello, this is Jahidul Islam Apurba, and we are going to learn about a problem that is given by our honorable teacher, Dr. Sadiq Nabi sir. So, there is a situation, and the situation with the production sector. So, we are going to understand about an economy that is involved with the production sector, and the production sector produces many goods, and but there is a noticeable thing that each farm produces only one of them. That means each and every individual farm produces only an individual good. Another thing that is noticeable is that the economy is in Walrasian equilibrium. We have already known about the Walrasian equilibrium, and in the later stage we will go through the definitions. So, a Walrasian economy equilibrium and with strictly positive prices, and the consumers utilities of consumption goods, all consumers utilities of, that is, of consumption goods, and all farms marginal products of inputs are strictly positives. So the last condition is consumers utilities of consumption goods and farms marginal products of inputs are strictly positive. Okay. So that is the whole condition, that is the whole environment that is very necessary for solving the two problems respectively. The very first problem, we have to show that the MRS, marginal rate of substitution, between any two consumption goods in the same is the same for each consumer. That means each consumer consumes two consumption goods, and that has the same marginal rate of substitution, and a marginal rate of substitution is equal to the prices of their good. That means is equal to the ratio of their prices. The second problem, we need to show that the MRS between in any two inputs is the same for each farm and equal to the ratio of their prices. That means each farm that which are facing inputs, and they have the same MRS, and their prices are equal to the MRS. So that is the second problem. Okay, our solution has been given by our sir, and I am going to describe part by part, and I am writing down all the solutions to make things clearer for you. Okay, so from the very beginning, we are assuming that mu equal to ui ei theta ij yj, and belongs to L and J belongs to Z. So that is the our condition, very first condition, and it is the production economy. It is the production economy function, and we do already know the Walrasian equilibrium, and P belongs to R n plus plus, because R n plus plus means prices are strictly positive. So that is the Walrasian equilibrium condition. That is the main basic principles of Walrasian equilibrium. So if you are going to the solution part, for at the very first, you have to assume that I belongs to L, and the utility maximization problem is max x ui function of x, and that is a condition of price into x equal to price into e plus summation of theta ij pi j function of p, j belongs to z. Here necessary condition ki v vector ux equal to lambda p. That is the very first part of the solution number 1. But before going to that, we need to know some kind of definitions of the Wallacean equilibrium. Okay, so what is Wallacean equilibrium? Wallacean equilibrium is a vector of prices. Very important thing. Wallacean equilibrium. What is Wallacean equilibrium? Wallacean equilibrium is a vector of prices. Now, if you are going to that necessary condition, v vector ui x equal to lambda p, v vector. So you have already known that Wallacean equilibrium is a vector of prices. So that is the thing, that v vector is going to show you the vector of prices and consumption bundle for each agent, such that every agent every agent's consumption maximizes her utility given prices. That is another part of the definition, a consumption bundle for each agent. And another thing is every agent's consumption maximizes her utility given prices. So every agent's consumption maximizes her utility. And another thing is that the market should be clear. The total demand for each commodity just equals the aggregate endowment. Aggregate endowment. What is aggregate endowment? Aggregate endowment is the sum of the individual commodity. The sum and aggregate endowment is defined by the sum of the individual commodity endowments of all the agents in the economy. So what is aggregate endowment? Aggregate endowment is the sum of the individual commodity endowments of all the agents in the economy. What is endowment? Endowment is a donation of money or property to a non-profit organization which uses the resulting investment income for a specific purpose. That are all the definitions we should learn before solving the problem. So now we will get back to the problem solution. Sorry for that little disturbance. So the vector of uix and lambda p, that is the necessary condition, and the average between two goods, good number L and good number M. So the average between two goods, mu I x divided by mu lambda xl divided by lambda uix divided by lambda xm, price of L, price of M. So we are trying to describe a situation that is lambda uix divided by lambda xl by lambda uix divided by lambda xn. That is the whole MRS of goods L and M, and price L and price M is the basic prices for the two goods respectively. So that is the solution for point 1. Now we are going to solve the problem number 2. In the very beginning, for any firm Z belongs to Z, the profit maximization problem is pi j function of P equal to maximization of prices into Y quantity Z, Yj E lambda Z. So Okay. If the farm produces only one output, the thing that should be noticed here, the farm is producing only one output. The profit function can be written pi function of P comma W equal to maximization of profit function of x minus W x. So here P is now the scalar price of output. P is now the scalar price of output, and W is the factor prices, and inputs are here. Inputs are measured by the non-negative vector x. X is the inputs and it is non-negative vector, and P is the output and it is scalar price, and W is the vector factor prices. That are all the definitions you should memorize. The other thing is, first order condition for the profit maximization problem is function of P lambda del f function of x by divided by del x1 equal to W, and W is the vector factor prices, and you need to show that the average between any two inputs is the same for each farm and equal to the ratio of the prices. So here the prices is W, and W is a vector factor prices, and MRS is lambda del fx divided by del x1, and it is equal to the W. So we have shown that the MRS between any two inputs are thus equal for the ratio of their prices. Thank you all for listening to me. I think I did a little some mistakes in my video presentation, but in the later stage I will do my best to improve myself and give you some more understanding topics, more understanding concepts, and till then, tata.